Hello viewers, I'm Dr. Mala Das Sharma. Welcome you to my tiny YouTube channel MALACHEMPHILIC. Today I'm going to start video number 123 and this is the episode number 63 of Chemical Thermodynamics, and the topic of this episode is conditions for phase equilibrium. So let's start. So condition for phase equilibrium. See, already I have written here, phase equilibrium involves the same chemical species present in different phases. The system consisting of a number of phases and the same chemical species should be present in different phases. And then this phase equilibrium, 1 minute. Say here, glucose in the solid phase is in equilibrium with the glucose in the aqueous phase. Now, what are the conditions for phase equilibrium? If equilibrium exists between the different phases of a system, here it is closed system, ours is closed system, then what are the conditions must be fulfilled? Number one, first condition is thermal equilibrium. Thermal equilibrium. Second one is mechanical equilibrium. Mechanical equilibrium. And third one is material equilibrium. Okay. Now one by one I'll explain it. So our first one is thermal equilibrium. Thermal equilibrium. Equilibrium I'm writing it this way. See, this is this is my closed system, and already I am considering that here we are considering only pressure volume work. Closed system, and this is the two phases. This phase is beta phase, this is delta phase. Now this equilibrium exists between the two phases means three conditions must be satisfied: thermal, mechanical and material. Now thermal equilibrium means, that means at thermal equilibrium, this temperature of these two phases, say this phase my temperature is, say it is T beta, and for this phase temperature is T delta. So at thermal equilibrium means the temperature of this beta phase must be equal to temperature of the delta phase. This I have to prove it, right? Now suppose that from in the beta phase, here the entropy is S beta. Here delta phase entropy is S delta. Okay. Now consider that from beta phase to delta phase, this small del Q amount of heat is transferred, right? Then that infinitesimal, that means small change I am considering. So that infinitesimal change in entropy at beta phase, what that will be? Beta phase, that will be, see, delta S beta, that will be is equal to minus del Q by T beta. Okay, heat released by this phase, so minus del Q by T beta. Right? Now, infinitesimal entropy change in delta phase. Then what? So here it is the state function, no? So ds beta. So ds delta, that will be is equal to plus del Q by temperature of the delta phase, right? Then this overall entropy change of the two phases, that means entropy change of the two phases, what it will be? That will be is equal to ds. ds will be is equal to ds of beta phase plus ds of delta phase, right? So now if I write that overall entropy change, overall, not in the infinitesimal or small change. So delta S will be is equal to delta S of beta phase plus delta S of delta phase. Delta S of beta phase is Q by T beta. It is overall heat released, so it is minus, plus here it is same amount of heat is absorbed, Q by T delta. Okay, so this is overall entropy change, right? Now, at equilibrium, delta S should be is equal to 0. Overall entropy change should be 0. We know for irreversible process, what happens? Entropy increases and at equilibrium, entropy will be maximum where the entropy change is 0. So, therefore, at equilibrium, what can I write? I can write this minus Q by T beta plus Q by T delta is equal to 0, right? So therefore from here I can write this 1 by T delta minus 1 by T beta is equal to 0, right? So from here I can write that is 1 by T delta is equal to 1 by T beta. Therefore, T beta is equal to T delta. This is the condition that both the phases temperature should be same. That we have proved it. Now next one, number 2 is your mechanical equilibrium. Mechanical equilibrium, right? So here you write at mechanical equilibrium, what happened? Pressure of the phases which are in equilibrium must be same. So in that case, in our case, it is pressure of the beta phase should be equal to pressure of this delta phase. Okay, this I have to prove it. Right. Now see, once again I am drawing here. So this is my system, closed system, and here is one piston. This is my beta phase. This is my delta phase, right? And here for beta phase, this pressure is PB and P beta, sorry. And this delta phase pressure is P delta, right? Now, Suppose this piston is moved from here. So now this is the volume of the beta phase. This is the volume of the delta phase. Now piston is moved from here to here. So what happened? Piston is moved towards this side by the volume dV. So this beta phase volume increased by dV. So here volume is increased by dV. For delta phase volume is decreased by dV. Okay. So therefore work function at beta phase, how much it will be? Pressure volume work is equal to pressure P beta into dV, that is positive dV. And work function at delta phase, that will be is equal to minus, because here change in volume is negative. So minus P delta dV, right? So total work function say W, that will be is equal to how much it is? P beta, pressure of beta dV minus P delta dV, right? Now at equilibrium, total work function W is equal to 0. Okay. So what can I write? We can write P beta dV minus pressure of delta phase dV is equal to 0. Right? So from here I can write that is pressure of beta phase minus pressure of delta phase dV is equal to 0. Okay. Now here dV cannot be is equal to 0. This indicates either this one 0 or this is 0. dV cannot be 0. So therefore pressure of the beta phase minus pressure of the delta phase is equal to 0. So pressure of the beta phase is equal to pressure of the delta phase. This is the condition for the mechanical equilibrium, right? Now the third one. Third one is material equilibrium. Right? Now for closed system, where only we are considering PV work, pressure volume work only, then we have seen that already I have derived in my last video. Link is given in the description box. So what is that? Multi-phase system, summation of alpha, that means all the phases, summation of I, that means all the component, mu I dni, that is mu I alpha dni alpha, that should be is equal to 0. This already I have proved it. Now I have two phases. One is beta phase, one is delta phase. So this equation, how can I write? I can write that mu and the substance is J. Okay. Substance, the same substance in the two phases, that I am denoting by J. So what can I write? We can write mu J beta phase dnj beta plus mu j delta phase, then dnj delta phase, then 1 minute I'll write properly, dnj delta, that should be is equal to 0 at equilibrium, right? from material equilibrium, from this equation I have written, for my case, this should be equal to 0 when the equilibrium is reached, right? Now, this we are considering that substance J okay, flows from beta to delta phase. That means before reaching equilibrium, when the equilibrium is not yet reached, then J is flowing from beta phase to delta phase, right? And then we are considering that dnj beta, that we are writing it as minus dnj, because from here substance is going to delta phase. And here I am considering okay, and dnj delta, that is equal to plus dnj, right? Then this equation, what it will be? That is mu j beta dnj plus mu j delta dnj, that is equal to 0. From here I can write that mu j beta minus, sorry, one thing I have written wrong here because it is minus. So here I'll write mu j delta minus mu j beta, okay, dnj is equal to 0. I'll write in the next slide. So what we got? We got it that mu j delta minus mu j beta dnj is equal to 0. That means either this one 0 or this one 0. Now dnj cannot be equal to 0. So dnj, number of moles transfer, that cannot be equal to 0. So what I can write? Mu j delta minus mu j beta is equal to 0. Therefore, mu j delta is equal to mu j beta. So this is the condition. What is the condition? So we can write for closed system, PV work only, okay. Another condition, in thermal and mechanical equilibrium, okay. The condition for phase equilibrium is the condition, what I can write? Condition for phase equilibrium is, what is that? The chemical potential of the substance must be same in all the phases. So this is the condition. So the three conditions for phase equilibrium, one is thermal equilibrium, temperature of the phases should be same. Second one is mechanical equilibrium, that is pressure of the phases should be same. Third one is this material equilibrium, that is chemical potential of the substance in different phases should be same. Hope you have understood. Thank you.